All right, huge apologies there. Looks like my microphone wasn't on or operating. Let's see. So we're back. I don't know if anybody is still there, but if you can't hear me still, let me know. I'll try to review what I've developed so far. I don't know that anybody's here, but okay. Sorry about that. There was no audio for the first part, so I'll probably just delete that video. But let me go ahead and come back over here. Hopefully you were reading along at least. What we're doing basically is we're given these inputs where I've got up, left, right, down, going over so many units, and so it starts at this central port. There are two wires. And this input here, this right, corresponds to going right up, and then up 5, and then left 5, and then down 3. Then the second wire here goes up 7, right, right 6, down 4, and left 4. And what we're going to do is we want to know where these two wires intersect. The wire intersecting with itself doesn't count. But the wires intersecting with each other does. And what we're wanting is just one solution here. The intersection point that is closest with respect to Manhattan distance from the central port here, and that's going to be this X right here, this highlighted X, which has a Manhattan distance of. Manhattan distance is just going to be not as the crow flies, but if you have to, you can't walk through buildings. So if you just go on a grid over 3, up 3, that's where we're getting this 3 plus 3 is equal to 6. Okay. So what I've done so far is just for now, I'm parsing the first wire here and trying to draw it. I have created a grid, initially an n by n grid here, and my central port is going to start in the center of that grid, roughly the center of that grid. I'm going to print that grid, and we get this. Here, let me go ahead and run this again, and you can see that it's initially empty grid here. And then in the first, we parse out the first wire here using strtoke, starting the wire at the central port. And then we parse out the direction, up, down, left, right, U, D, L, R. And we also get the distance here. And then what we're going to do is we're going to, Y's are our first coordinate here, X's are our second coordinate. So it's going to be a little bit different orientation, but that's fine. If we're going up, then we're going to increment the Y along the Y-axis. If we're going down, we're going to decrement it. If we are going left, we're going to decrement the X value, increment the X value if we're going right, okay? And all I'm doing here is setting these equal to 1 so that we know where the first wire was. Right? I've successfully tokenized that first string, and then I print out the board again. And let me go ahead and modify this so that we're printing it out, printf, I don't know, some delimiter here. All right. Give it some space. All right, there's the first board, right? A 25 by 25 board. It's all initialized to dots here. Now here's my first wire. It doesn't match over here because of the way that I'm printing it. And if I start here, it's actually going down instead of right, and then it goes up, right instead of up, and then left or up instead of left. And so what I actually want to do is I want to take the transpose of or not the transpose, but I want to turn this, or rotate this, that's the word I'm searching for, rotate this 90 degrees counterclockwise, and then this will match up. All right? Not exactly, though, because let's verify that we're doing... let's see. So I don't know. Let me double check my work down here. So we're incrementing. We probably should be doing this afterwards. That's the problem here. because we weren't going far enough. There's a gap of 2 here, and in the input there's a gap of 1, so this will probably be a little bit better. It's still not going to print it oriented like this, but this is the central. In fact, let's go ahead and do that. Do this. Let's go ahead and make the X and Y value of the central port. Let's go ahead and give that a negative value so that we can actually print that out. So board, or what did I call, ARR sub CPY, CPX is going to be -1, right? And then up here, if it's -1, I want to visualize that. If it's -1, we'll go ahead and print, not a dot, but we'll print that O. There we go. There. So there's the visualization of, there's the central port, and then I want to make sure that I'm going the correct number of units here. So I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then we go 1, 2, 3, 4, 5. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? Remember that it's 5 and 5, and then over 3, 1, 2, 3. And it looks exactly like this one over here, except of course that it's oriented incorrect. So you can go ahead and turn your head like this and orient it correctly. Or if you really want to be a stickler about it, you can go back and rotate this 90 degrees. That would require just a little bit of thinking on how to do that. All you need to do is, let's see, should we do it? I think it's going to be something like n minus x or something, -1 or something like that. Let's go ahead and just keep it for now, and let's worry about the actual exercise here, and then we'll come back and that'll be our gravy if we really want to. So there's the first wire. Again, copy pasta. Don't do that in general. Second wire. All right, so here's wire 1, wire 2, wire 2, and we're parsing out wire 2, and we've already declared t, so I'll go ahead and just reuse that variable. Otherwise, these were locally scoped to the loop, and that's going to be the same. Then we've got, instead of wire 1, we've got wire 2, wire 2, wire 2, and wire 2. All right. And now we do want to be careful here, because if we just set this to 2, let's go ahead and see what that looks like. All right. So we've still got the wire 1 here. Now what we've got, oops, we didn't do wire 1, wire 2, wire 3. We still have a bug here. Wire 2. Wire 2 is up 7, right 6, down 3, left 4, but we're only getting 1 difference here. Oh, there we go. Duh. Right. It never changed because I never changed that. Again, this is why you don't copy pasta. Right? You never get everything right. There. So it kind of looks like that. Let me go ahead and verify that. So instead of going down or up, I guess we're going right, but we're going 1, 2, 3, 4, 5, 6, 7 units. 1, 2, 3, 4, 5, 6, 7 units. And then we're going over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then we're going down and over here. This is our intersection point here, and this is our intersection point here. So the way that I'm going to deal with this now is I'm going to put this into a condition. Right? I want to know if it's already been set by wire 1. Okay? If that's 1, then we know that wire 1 already crossed here. So what I'm going to do is I'm going to actually set that equal to, say, 3. Right? Otherwise, I'll set that equal to 2. Oops. All right. Okay. Now, for this simple example, it's going to work. But there is an issue here that I think that we're going to hit eventually with the actual input. In that, remember, a wire, it gave us a strong hint there that a wire could intersect with itself. And if a wire intersected with itself, for the first wire, that's not going to be that big of a deal because I set everything to 1. But for the second wire, that is going to be a big deal because it's going to check, is it already 1? Well, if it was already 1, then it's going to set it to 3. Otherwise, it's going to set it to 2. Well, what if it's already 3, right? So if it's already 3, let me go ahead and put just future-proof this, just in case. If it's equal to 3, then it's kind of like it already both wires were already there, so I won't do anything. In fact, what I'll do is maybe I'll keep this here because I'm thinking maybe they want in the second part a count of the number of times it actually intersects there or something. So I'll go ahead and future-proof this. And I'm not collapsing these two conditions down simply because I do want to future-proof this in case I want to distinguish between these two cases in the future. But otherwise, I'll say that else. In fact, I'll make this even more explicit. If nobody's ever visited this before, if it's 0, then we set it equal to 2. Now I can of course rearrange this that if it's 0, then that means that it's clean. No wire has ever been here before, and so we set it equal to 2. And that's actually probably should be the first condition here. Right? If it's unvisited, then we set it equal to 2. Otherwise, if it's equal to 1, then we set it equal to 3. Otherwise, if it's equal to 3, then we'll keep it at 3, but maybe eventually we'll want to change that and like increment a counter or something if we want to know how many times it intersects. Otherwise, there's really no other possibility here, so I'll go ahead and print a warning message. Value is invalid. All right. Just as a sanity check. All right. There should not be a value there at all. Well, I don't want that when it's equal to -1, right? So maybe that's what I want. If I ever cross the central port again, let's not change it. All right. Else if there we go. Otherwise, if it's clean, we'll set it equal to 2. Otherwise, if wire 1 has crossed it, we'll set it equal to 3. Otherwise, if it's crossed before, we keep it at 3 again. Again, I'm kind of thinking ahead here as to all possibilities of what they would want us to do eventually give as an answer here. All right, so, oops, forgot my semicolon. There we go. Just as a quick sanity check, make sure I didn't break anything. We should still get this 3 and 3 here. Now what I want to do is I want to go through this and find the Manhattan distance of all these points. I'll just do it brute force. Right? What I mean by that is I'll just compute the Manhattan distance of every single one. So min distance, int min distance equals, we'll just set it to something very large. N times 1,000, right? Then for each value, I will compute the Manhattan distance. So I think I've already used distance before. It's in a different scope, so I could go ahead and go with distance, but I'll just go ahead and go dist here. And I've got, what I want is, I want the distance from, that's why I put these into two separate variables here, CPX and CPY, and I and J, so CPX minus J, because J corresponds to X. It doesn't really matter here because what I'm going to do is I'm going to do the absolute, the way that you get the Manhattan distance is you just take the absolute value between two X coordinates and that gives you the Manhattan distance this direction. Take the absolute value of CPY and X and I, and that gives you the distance in the other direction. Right? And if that's the distance, and well, I probably want an if condition here, of course. If this is equal to 3, that's an intersection point. Right? Then I compute the distance. And if the distance is less than the min distance, then I update my min distance. Right? And then let's print it out at the end. All right. So I've got my visualization, which might come in handy for debugging purposes, but oops, 2500. Oops, there we go. That's it. So if it doesn't matter, I and J, right? There we go. All right. The min distance here is 6, which it corresponds to the walkthrough example here. Here's another example. The distance should be 159. All I'm going to do is replace my two hard-coded strings up here. I don't want to get rid of those, so I'll go ahead and save them off. Wire 1 and wire 2 should now be these values, though. And here's the second wire. And there we go. And the distance here was 6. The distance here should be, what was it? 159. Let's run this again and see if we get what we were expecting. We don't have a segmentation fault. And that's probably because, let's see, okay, now these are going 55, 65, 75, so let's go ahead and up this value. This is why I parameterized it, so that it could be larger. Now at this point, the visualization is going to be much more difficult to verify, so that's why it was of a limited value here. Oops, we're still getting a, let's see, if we go, let's go with 1,000 in both, and this certainly is not going to be viewable. Right, there we go, min distance of 159. What I'll do is I'll go ahead and get rid of these print boards here. That helped us visualize it and make sure that we were actually doing things correctly. But once it gets too big, the visualization becomes meaningless for us. All right, min distance 158. Let's go ahead and make sure that this last one also works, 135. There we go, and that's probably still big enough. 135, so that works. Okay, so last one, let's actually get our real input here. All right, let's get my puzzle. So these are really, really long lines here. I'm going to have to be very, very careful in the distance here because I already see that, oops, and it broke it. Oh, no, this is all one big line. There we go. It's just going down to the next line here. I already see like values of 1,000 going left or right 1,000. So we're probably going to want to go, I don't know, 2,000 here. Let's see if that will work. If that's enough. That's going to be a 2,000 by 2,000. So that's why I did this dynamically to begin with, because I thought it would be big. If we tried to do this statically, 2,000 by 2,000, that's going to be 4 million integers. 4 million integers, that's going to be 4 bytes each, so 8 megs. You're more than abusing the stack space there, and it's not going to work. All right. And we're getting a segmentation fault. I'll go ahead and up that again. That's not that big of a deal for the heap, of course, because 3,000 by 3,000, that's 9 million. 9 million times 4 bytes each, that's going to be 36 megs. That's nothing. Really. I'm starting to suspect that maybe I've got a bug somewhere, because this should be 10,000 by 2. That's getting up there. Yeah, I'm starting to suspect that I've got a bug somewhere instead. That's fine. It gives us an opportunity here to do some sanity checking. So what I'll do is I'll do some error checking here. If at any point, if wire 1y is less than 0 or wire 1x is less than 0, then we know that they're bad, that we've gone off the grid. Wire 1y, if that's greater than n, or wire 1y, if that's greater than n, or greater than or equal to n, then we know that we've gone off the grid here. And what I'll do is I'll go ahead and print an error message. I'll print all those out though. %d, and the line, wire 1x, wire 1y, and I think I've got a bug here already. If x is less than 0, if y is less than 0, or if x is greater than n, equal to n, if y is greater than equal to n, then I'll print out an error, and we'll just go ahead and exit. All right. And I'll do the same thing when we're tokenizing the second one. I'll do it right here. And these are wire 2, 2, 2, and 2. And this will at least tell me if it might be going off the grid might be responsible for this. Yeah, okay, so 1,500. That's too little, so let's go with 2,000. Try this again, but I was still getting a seg fault. All right, still okay. 20,000 by 20,000. Let's see if this works. It's going to be huge. Oh. Uh-oh. So value is invalid 2. Value is invalid 2. Oh, okay. So let's check these out. This is when it's going to hit the central port again. This is when it's unexplored territory and you're going with the second wire. This is where you hit that, you cross that first wire, so we're going to indicate that that's 3. Otherwise, another thing that I forgot to take advantage to take care of is, what if it's 2, right? Then we'll leave it as 2. That indicates that you crossed yourself again, right? And we don't have this check on the first one. Now I'm kind of suspecting that in the second part here, we're going to have to do this on the first one as well. It might ask you, where does wire 1 cross itself closest to the central port or something like that. But fortunately, we did get an answer here. In fact, we're crossing ourselves on wire 2 here many, many times. But I'm going to go ahead and assume that this is the correct answer. Of course, we could do regression tests and go back and make sure that my changes here didn't affect anything. But let's just go ahead and pull the trigger. All right. Of course, I always cross my fingers. And yay, we got the right answer. Okay. 1 gold star, closer to Santa. All right. Turns out that this circuit is very timing sensitive. You actually need to minimize the signal delay. To do this, calculate the number of steps each wire takes to reach each intersection. Choose the intersection where the sum of both wires' steps is lowest. So the two, okay. If the wires visits, if a wire visits a position on the grid multiple times, use the steps value from the first time it visits that position when calculating the total value for a specific intersection. The number of steps a wire takes is the total number of grid squares the wire has entered to get to that location, including the intersection being considered. So no longer Manhattan distance away from the central port here. Instead, it's probably going to be this other one here that we come up here, and this wire comes up and over and down, and that is the answer that we want here. But the answer that we want is how many steps did it take to get there? The intersection close, okay, sorry, it's still the same one. The intersection closest to the central port is reached after 20 steps by the first wire and 20 steps by the second wire. Okay. However, the top right intersection is better. Okay, so yeah, I was right that this is the one that we want because that's the first intersection point. The first wire only takes 15 and the second wire only takes 15 to get there, a total of 30 steps. Okay. So it's giving us different answers here. Basically, we want the first intersection point. And because I've future-proofed this, I think we're in a good position here. I don't want to lose my code here, so I'm going to duplicate this. All right. So we don't need to worry about the first wire intersecting on itself. Well, actually, we might. Let's see. What it said something about that. If a wire visits a position on the grid multiple times, use the steps value from the first time it visits that position when calculating the total value of a specific intersection. Okay. Is that going to matter for the first line? So if a wire comes in and hits itself again, then I don't think it's going to matter because we want the first the first wire is not going to matter. The second wire does. In other words, we the first time it hits that that first wire, that's the one that we're interested in because Manhattan distance. We still have to know how many steps wire 1 took to get there. Darn it. So we're going to have to keep track of that. So what I mean is, wire 1 is going to go all over. It might intersect with itself. What we're going to want to know is, for each grid point, what are the number of steps it took to get there? Because if it intersects on itself, we don't want to overwrite that number. So unfortunately, we are going to have to keep track of of more information at this point. This more information means that we're going to probably want another array here. Right? Num steps wire 1 is what I'll call it. Right? And num steps wire 1, num steps wire 1. Right? And it's going to be a one-to-one correspondence with our array over here. Now, if I knew about this to begin with, I would not have used integers. I would have used some sort of a structure that kept track of all this information in one structure. The x and y value, of course, the x and y values would be implicit with a 2D array of structures. But I would also keep track of how many times wire 1 was there. How many steps it took for wire 1 to get there to begin with, etc. Right? But I'll go ahead and go with this for now. Right? And when we're parsing out wire 1, let's see. So if we're out of bounds, fine. Otherwise, what I'm going to have a check here now. If this is equal to 1, in other words, we've been here before. So so do nothing, right? So we've been here before. We have not been here before, right? Or nah. If it's 0, then we've not been here before. And at that point, what I'm going to want to do is I'm going to want to set it to 1, but I'm going to want to set it to 1 no matter what. But I'm also going to update that number of steps array. Right, this is getting pretty hackish at this point, but let's see if we can get an answer at least. and we've not been here before, so I'll go ahead and timestamp that with a counter. Now I'm going to need that variable, of course. That counter would have been an integer. Right. And let's go back and understand how many time steps it took. So let's see, 15. So 15. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's not counting, where you're starting here. It's just counting the pure number of steps that you take. So I'll go ahead and start it out at 1. Timestamp it with that, and then no matter what, you're going to increment your counter. Okay? That tells us how many timestamps, and then of course we're not, if we have been here before, else, right? We have been here before, ignore the timestamp. Okay? Now down here, the first time we intersect, that's going to be that, we've seen wire, not the origin, not something that we've seen before. It doesn't matter if we loop back in onto ourselves. What we're interested in is here. We now see wire 1. Right? This is the first point, because we're going in order, that we intersect. Compute the number of steps. Okay. So I don't care about this value anymore. In fact, I'm going to stop my program here. Right. So this is the first time we've seen this. I want another counter, and for that I'll just reuse that variable. Counter is equal to 1. Right. And then every time, in my for loop here, there we go, counter plus plus, right? Because we've already incremented. And all I'm going to do is I'm going to printf count wire 1, %d, wire 2, %d, and then sum. That's what we're actually interested in, %d, just for convenience so I don't have to do it in my head. It's going to be that array that I originally had, which was called num steps w1. So num steps w1 of these values here. That's where we are right now. And the counter. And we did the counter before, up here. That's the number of steps it took to get us here. And then the sum of these two things, which I'll just go ahead and put into a variable here. There we go. Sum. All right. Let's just run it and see if it actually runs. Oops. Oh, ran the wrong thing. Compiled the wrong thing. Okay. So there's the first time. There's the sum. It took that many steps to get there. That many steps for wire 2 to get there. So that's probably our solution. I'm not going to submit that because what I want to do is I want to make sure that these other ones are correct. For example, if we come back up here, I still have my test cases up here. If we come back up here and I'll cut this down to, I think 1,000 was good, just so that it runs faster. All right. Let's go ahead and try it with that first test case. All right. There's the min distance again, but looks like we're off by 1 here, so I'm glad that I checked this. Looks like we're off by 1 because I started the counter at, what was it again? I started the counter for wire 2 at 1. Right. And then we, okay. So now we did it at the end here. We're just off by 1. Well, Let's see if that if it agrees on the other one. So if we just subtract 1, then we'll get what we want for the first one. And I'm pretty sure that we're off here, because if you've got a wire that goes over here and you've got a wire that goes over here, the number of steps to get there because of Manhattan distance has to be even. So I'm pretty sure that we're off by 1 here. But let's the other one is 610 steps. So let's try the second test case here. Get rid of that. Try this again. So if our bug is consistent, 625. So no, we're definitely not off by just 1 here. And yeah, 630. Oh wait, we're really off there. Get rid of this and this. That's unfortunate. All right. Let's see. Hopefully I'll be able to figure this out in a timely manner, but I've got another obligation, so I don't know if I'm going to be able to get this done. All right, there's 31. So wire 1 was correct. It took 15 steps to get there. Unfortunately, they're not giving us the full picture here. It took 15 steps to get to that other one. And we're off by 16 here. So I'm going to have to really think about this. This is going to represent, I think that this is correct. Then after all that, that's when we do the counter plus plus. So I'm thinking we probably should do the same thing down here after we check all this stuff. All right, that one's now correct. And it was probably just contributing a lot more increments than it should have been. Because, of course, because each one of these is doing, say, 85, 83, and so you'd be off by 83 if this is or some value 0 to 83 if this is the intersection, if the intersection occurred on that movement, basically. So let's go ahead and try this again with the second test case, 624. I don't think that's correct though. 600, yeah. Just make sure that I've got my samples correct. That's going to be R75, 30, 83, up 83, left 12, 14, 17. Yeah, this is correct. This should be 610 steps. Darn it. I'm going to probably admit defeat here, because again I've got to do something, but I will definitely come back and try to fix this. Unfortunately, they're not giving us a breakdown here that I can verify that is it wrong, is my understanding wrong on the first wire, or is my understanding wrong on the second wire. But if we come back up here and read this really quick, I'll do it one last chance here. The intersection closest to the central port is reached after, let's see, on the 8, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2 steps. Oh, I know. Well, no. I'm thinking it has something to do with... No, we are checking within this loop here. This is wire 2. And we're only going up by 1 each time. And if this is the first time we've encountered the first wire, Oh, you know what? I think wire 2 could intersect with itself several times before getting to this, and we're off because, well, we were, no. Then the actual answer would be higher than what we have, and that's not the case here. The actual answer would be lower than what we have. And no comments from the peanut gallery. So I'm going to have to admit defeat here and take a look at it offline. And maybe I've got it figured out by class tonight at 5 o'clock. But this is why these are excellent exercises to go through, because it gives you a lot of opportunity to think and rethink and refactor your design. Right? I was thinking forward a little bit here by thinking, okay, well, I'm going to have to distinguish all these possibilities, but I wasn't thinking forward enough, because if I had thought forward enough, then I would not have designed it like this, where it was just an array of integers, 0, 1, or whatever. I would have redesigned it so that I'm keeping track of a lot of more information. Now that I've got everything that full knowledge of what they're going to want me to keep track of, I can go back and I can redesign a structure to keep all these things clear in my mind. Maybe even keep track of all of the counter intersections of how you got there. But otherwise, hopefully I'll be able to have it figured out, and we can either go over it in class, or what I was originally planning in class anyway was to take last year's final and doing it. So sorry that I was not able to get it done today, and sorry for the first streaming that did not work because my microphone was not enabled. If at all possible, if I do have a much better, well thought out design and a solution by 5 o'clock, I'll go ahead and stream that really quick, cut to the end of what I actually did to achieve this. All right. So see you tonight at 5 o'clock.